All right, since I know everyone's going to be ready and everyone is going to be paying attention because Gabriel needs to pay attention and not that drama that's on his phone because otherwise he's going to be upset, right? We don't want to see Gabriel upset. We don't. So, since I know we're all ready, let's see if we're ready. Okay, are we ready? All right, so, you ready? No? Okay, all right, so I'll give you a second. So, let's see. All right, class.
Yes.
Thank you. Okay, you better. Speak directly to the clown's head. Are you ready?
Sure.
Sure, we got a sure. Okay. All right, so what page are we on in the notebook? So you're writing number 39 on here because you know what's going to happen? A lot of people are going to go, when it's time to turn in your notebook, be like, hey, what page goes where? Guess what? There's not going to be another notebook check. But do you think you want to use these notes for this test coming up? Most likely. Do you think you want to use these notes for the final exam that's coming up, which is going to cover everything? Most likely, right? Okay. Events involving and conditional probability. Blah, 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 blah. Okay, independent events. Two events are independent events if the occurrence of either of them has no effect on the probability of the other. Now, so here is my example. I'm going to take this coin. Oh, where? I put it away. I don't know. It's this giant, big ass peso. I don't even know what it is. Anyway, it's kind of cool looking. Anyway, so
What's a peso?
I think it's like Mexican money. Okay, anyway, so peso right here. I'm gonna flip this right here. I think there's a heads and tails on it. Kinda. Yeah, anyway. So boom. And it's now tails. I'm gonna flip it again. But if I flip it a second time, since I already got tails right now, do I have to get heads this next time? No. Why? They have nothing to do with each other, right? Have nothing to do with each other because the word of the day, the vocabulary of the day is that these are what, Gabriel? Say what? I'll put this over here because I need Gabriel. I know you do, and you know what? I will help you out. Okay, it charges a lot better away from you. I'll go put on my charger over here. Okay, I got you, fam. I got you. Okay. So, the word of the day is what, Gabriel? Do you know what's sad? I know that's true because you were playing on your phone instead of actually doing what you got to do. Independent events, because the first flip of that coin had nothing to do with the second flip. So it makes them independent of each other. Okay. So, right here, it says the and probability of events with independent events. A and B are independent events. Thus, see this, the way it writes it, there is a multiplication. So we're going to multiply the probability of A times the probability of B. Yes? Yeah? You sure? Good? Yeah? Yes. Okay, good. Let's keep going. See if we're paying attention now. A U.S. roulette wheel has 38 numbered slots, 1 through 36, 0 and 0, 0. 18 are black, 18 are red, 2 are green. The ball could land on any slot with equal probability. What is the probability of red occurring on 2 consecutive plays? First, how many reds do we got?
18.
There's 18. Out of how many total?
38.
38. So, do you guys know what those roulette wheels are? Like the spinny wheel, they drop a ball in there and it's got a select on it at the end, right?
Yep.
Now, serious question here. 18 out of 38. So that's the first time I got a red. But what about the second time? What's the chances of it getting red for the second time?
18 out of 38.
So it's not going to change, right? Because it is independent of the first time. I multiply those together. And I know everyone's there using NumWorks because that's what they do. Okay? Don't complain that I stole your phone and you can't use your calculator because no damn well you were just texting. Gabriel, is that an earbud in your ear? Is your music still playing? Is that what it is? Oh, okay.
I just forget I have it on.
I know, right? It's kind of like like decoration. You gotta like flex on everyone, and be like, "Yo, I afforded those new AirPods," so it's a fashion statement, right? Yes, that guy.
So I got 81 over 361.
81 over 361. Now, give me that approximation. What's that decimal? 0. What?
22.
224. Right? Now, that's the decimal, but after the decimal, I want to find the percent. How would I find the percent?
Just move the decimal twice.
Times by 100 or move the decimal over twice, right? So I would end up with 22.4% chance of getting red and then red. Yeah? Okay. Is that pretty easy? Good. If two or more events are independent, we can find the probability of them all occurring multiplying the probabilities. Probability of a baby girl is 1 out of 2. So the probability of 9 girls in a row is used as 1/2 to the factor of 9. Okay? So, just so you know, I got in trouble last year for using the same problem as a warm-up. Because my warm-up, I said, hey, I had a student sat up here, gave a nickname, Lionel Richie. I'm like, dude, Lionel Richie last week knocked up 8 girls. Okay, what's the probability that all those kids going to be boys? That's crazy, right? Okay, I got in trouble for that. They gave me a talking to. They're like, really? I'm like, no, really. Look, here's the problem in the book. Okay, I just related it to something that students will understand. Okay? But they're like, really? I'm like, no, seriously. Look, it's already there.
You actually got in trouble.
Yeah, they'll give me a talking to. I'm like, come on now. I'm like, you want me to make real world examples here? Okay? Yeah. I got homie knocked up 8 girls last weekend. That's where it is. Okay? Anyway, let's do the math. So the math on this one, so when you put in the calculator, you have to use parentheses, otherwise it's not going to be correct. If you got 1 over 2 as your answer, that is incorrect. The correct answer is supposed to be 1 over
512.
512. Very good, because as I plug it in, if you use parentheses in the correct way, it's going to take both of them to the 9th power, which is going to give me about
0.001.
0019, like that. It's almost like I did this problem already. Yeah, trust me, I'm not that smart to actually know these. And as a percent, I move it over, so it's going to be 0.19%.
2.
Oh, if you want to put 0.2, fine, yeah. If you want to do 0.2%. But it's less than 1%, isn't it? Is that pretty easy now? So far?
Yeah.
Okay. If the probability of South Florida will be hit by a hurricane in any single year, it is 5 out of 19. Okay, what's the probability South Florida will be hit in a hurricane? 3 consecutive years. So, my probability is going to be 5 out of 19. And it's for how many years?
3.
There we go. Was it like 68 something?
Yeah, 6800.
You got the pass already?
Yeah.
6-8,
5-9.
5-9,
Yep.
which is going to give me as a decimal
0.018.
And as a percent, that is going to be 1.8%. Muy fácil? Sí, sí. Josué. Muy fácil. See? Hopefully we're good. Alrighty. Now, probability of not getting hit by a hurricane in 10 years. So if the probability of yes is 5 out of 19, so what would be the probability of no?
14.
14 out of?
19.
Very good, because both together have to add up to 19, right? So if you want you to think about it like this. There's 19 students in this class. 19 students in this class. 5 of them say yes. Okay, 5 of them say yes. So now, would it be pretty easy, just mathematically thinking about it, if there's only 19 in there, 5 say yes, how many would say no? There's 14. That's where we're going to get the not from. This is the not statement. Or yes or not. Okay, so it's going to be 14 out of 19, and for how many years is this one? For the next 10 years, so it's going to be to the 10th power. All right, this one's just going to be yeah, don't give me the fraction on this one, because this one's going to be interesting. What's that going to give me? Just give me the decimal.
0.50.
5.
No, 0.047.
0.047. Like that?
Oh, I got it.
Yeah.
Yes? Okay, good. And then as a percent, move it over twice, there is a 4.7% chance that it will not be hit by a hurricane in the next 10 years. So is that a really good chance? No, that's not a very good chance. Does that make sense? Questions, concerns, complaints, conspiracy theories? No conspiracy theories either? Alright, I got one though. Okay. Donald Trump or someone in the Trump family is a time traveler. Have you heard about that one already? That
The
one's
government is lying.
okay. Dependent events. Okay, I got my deck of cards here. This is what's going to be an example of a dependent event. I'm going to take out my jokers. How many cards are here? 52. There's 52 in a regular deck of cards. These two right here, they don't count. So, probability, first one. Okay, I'm going to go with, I got a jack of spades here. That's my first card, right? I got a jack of spades. How many cards are left?
51.
There's 51 cards. So now, this is now going to be considered a dependent event. Because now, my second card depends on what I got the first time. So, thinking about this, how many jacks are now left in this deck? 3. So initially there was 4 jacks, but now there's only 3 jacks, right? And now to get a jack in the first place, that would be 4 out of 52, right? Times, this is what this translates to. B, given that A has already occurred. That means we already got a jack. So how many jacks are left? 3 jacks are left out of how many cards are left?
51.
51. That's what this right here means, given that it has occurred. So with dependent events, I need to actually use that information. You won a free trip to Madrid. You could take 2 people with you, all expenses paid. Bad news, 10 of your cousins have appeared out of nowhere and are begging you to take them. You write each cousin's name on a card, place these cards in a hat, and select one name. Then you select a second name without replacing the first card. If 3 of your 10 cousins speak Spanish, that's important. So 3 speak Spanish. So how many are not speaking Spanish? 7 are non. That's important. Find the probability selecting 2 Spanish-speaking cousins. So first, what's the probability of getting a Spanish-speaking cousin?
3 out of 10.
3 out of 10 because I have 10 total there, right? Now, I am selecting 1 from there, and I just so happen to choose one of my ones that are Spanish-speaking. So how many is going to be left? 2 out of 9. 2 out of 9 for this next one. Do a little math, bam, 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 and I get 1 out of 15. But as a decimal, that's like 0.06 repeating. I don't know, 0.06 repeating. Is that it or no?
Yeah.
Okay. And so now from there, if I turn that into a percent, I move it over twice. It's going to be 6.6 repeating percent. Does that make sense now? You guys feel good about that? Caleb, you good? Right? Seemed pretty easy, right? All right. So now that we know that, we're going to stop there before we actually go into any of the rest of this stuff. So your homework is available. You can start working on some of the ones that you can. Okay, there is a lot of them that you can't. Okay, we just have a couple more examples that we're going to finish up next week. And you guys are all going to like, share, and subscribe. Hit that notification button. Support my channel.